Welcome to Lesson 3.2, Complex Numbers. We're beginning on page 127. And today your essential question is, first of all, what is a complex number? And then how do you add, subtract, and multiply complex numbers? Your first page here in the book goes through how to add, subtract, and multiply binomials. And then you combine like terms. You're going to use the same strategies for complex numbers. So go ahead and turn to the next page. A complex number is any number that can be written in the form of a plus bi, where a and b are real numbers, and of course I is equal to the square root of -1. All right, the a part is called the real part. So here's the example down here. All right, so that number that we're going to let a represent is what we call the real part. The b, or whatever number is in front of the I, is what we call the imaginary part. And your book has put together a Venn diagram of these new complex numbers, because a complex numbers involves the subset of real numbers that you're already familiar with and imaginary numbers that you learned about in the last lesson, a number like 2i, -7i. So let's practice identifying these real and imaginary parts. Under example 1, letter A, 9 is the real part and 5 is the imaginary part. And this number belongs to the set of complex numbers. Looking at part B, -7i, the real part of -7i is 0 because it doesn't exist. And the imaginary part is -7. Because the real / imaginary part is 0, because the real, not the imaginary, part is 0, the number belongs to these sets. It belongs to the imaginary numbers and the complex numbers. For number 4 under your turn, let's rewrite the real number 11 as 11 plus 0i. Makes it a little bit easier then to identify the parts. Of course, the 11 is the real part. And 0 is the imaginary part. This number, 11, belongs to real numbers, and it also belongs to complex numbers. Let's go to the next page. The way you add or subtract complex numbers is that you group like terms. Like terms meaning you group all the real parts together and you group all the imaginary parts together. As an example A here, we group the -7 and the 5 together, and we group the 2i, which is the imaginary part, and the -11 together, add the real parts, add the imaginary parts, you're just adding them like you're adding the coefficients, and you end up with a real and an imaginary part. So let's try B. We're going to take these and we're going to group them together. So the real numbers are 18, and I do have to distribute that negative, so that's going to give me a -2. The imaginary parts are 27i and a -3i. Let's add the real parts. 18 minus 2 is 16. Add these imaginary parts, so you're just adding 27 and -3, which gives me 24i. Adding and subtracting complex numbers is pretty straightforward. You go ahead and practice with your turn 7 and 8. Turning to the next page, we're going to look at how to multiply complex numbers. You're simply going to use the distributive property. So in example 3, letter A, we have the quantity 4 plus 9i times 6 minus 2i. So you distribute that 4 times 6, 4 times negative 2i, that gives me 24 and a negative 8i. Distribute the 9i, that gives me 54i, and 9 times negative 2i is a negative 18i squared, because we have I times I. Now when you see an I squared, we want to go ahead, here's our I squared, and we want to substitute in negative 1 for I squared. If you remember from yesterday's lesson, wrong pen, I squared equals negative 1. So we can substitute in a negative 1. And then at that point, you're just back to adding, and you're simply adding like terms. So we have a 24 and a negative 18 times a negative 1. So that gives me a positive 18. So 18 plus 24 is 42. And then you add the two like terms in the middle, which gives you a 46i. Let's try example B. Start using the distributive property because it looks like two binomials multiplied together. So we take negative 3 times 7, which is a negative 21. Negative 3 times 4i gives me a negative 12i. That's already written for us. We have 12i times 7. That gives me an 84i. And then 12i times 4i is a plus 48i squared. Let's go ahead and change that I squared at the end to a negative 1. So I'm just going to bring down these numbers, negative 21, 84i, and here we get 48 times negative 1. So combine like terms, we get a negative 69i, just negative 69. And then inside we have some like terms that we can add together, and we get 72i. When multiplying complex numbers, keep in mind that anytime you get the imaginary number I raised to a power 2 or higher, you're going to need to simplify that number. So if you're multiplying like I to the third, I to the fourth, even I to the sixth, be sure you simplify that before you start adding and subtracting like terms. It's your turn now to practice with 10 and 11.